All right, so this is the notes that was actually supposed to be kind of added to day 2, but it didn't happen, so we'll make it a day 3. That's all right. So just put it on the back of day 2 notes is probably the easiest thing to do. So here you notice I've basically given you the exact same thing as example 3 from the other day, but we'll call it example 4. So it's still a jury. It's got 5 men on it and 7 women. So same setup as the other day. We're still going to select 3 of them at random for some kind of interview. So let's actually calculate the probability. 1 of them is a man and 2 are a woman. We briefly mentioned that one yesterday, but let's see if we can remember how to do that. Again, when I look at probability, I think number of ways of getting what I want or being successful over the total number of ways the situation can happen. And what's actually happening here, just in general? We're selecting 3 people, right? That's just in general what is happening. So we are choosing 3 people, and why did I put a C instead of a P? Yeah, because I don't care what order I choose those people. If I choose them in a different order, it's still those same 3 people, correct? There's no assignment of any value to those people necessarily if they come in a particular order. But how many people are there, though? 12 people total, because 5 men and 7 women, okay? And what did we get for that yesterday? We did that already, right? 12. C3 was 220, right? Because we had that number from yesterday. So there's 220 ways that I can pick 3 people out of those 12. Now I would like to know what's the probability of that 1 of them is a man and 2 are women. We talked about this one yesterday, and you said this would be more probable than the other one, okay? Because of the setup. So we've got 5 men, and I would like to choose 1 of them. So what I need to know is if I have 5 of them, how many ways can I choose 1 of them, right? Because there are 5 of them. So this is really talking about the men, correct? And then the women, there are 7 of them, and I would like to choose 2. Again, you notice it is really choose 3, because I want 1 man and 2 women. So that's where the multiplication comes in, right? Well, the first one should be easy. 5, choose 1. If there are 5 of them, how many ways can you choose 1 of them? 5, right? Do you really need a calculator to tell you that one? I hope not. Okay, so 5. Now this one you probably do. This isn't necessarily something I would expect that you know right off the top of your head. If there are 7 of them, how many ways can I choose 2 of them? Anybody have that? 21. We have a question. On the TI-83s, it is under the math button. And then go over to PRB, which is the 4th option over. Okay, we are having some math difficulties. You hit the math button. Did you break the calculator, perhaps? All right, the calculator issue is that it is broken, so I will have to reset it. So what do we have here? 105 over 220, so approximately what percent? Very, very close to 50% chance, and I think it actually comes out if we approximate to, yeah, 48% or something like that, right? What was the other one? What was the one from yesterday? Like 4.5% or something like that? So this is incredibly more, almost over 10 times more probable, correct? Beyond that. So here are the questions that a lot of people fear when they get a probability question. And then I'm going to show you 2 ways of doing this one, and I'll show you that they come out, depending on rounding, to the same answer. So it's example 5. So it's the same thing, 5 men, 7 women. So you can say same scenario or something like that, whatever works for you on your notes. We're still selecting 3 of them. Now really what I want is the probability that at least 1 of them is a man. So take some time to write down what you need. And we'll do it 2 ways. Hopefully this will clear up when to use or, when to use and. and when to possibly use something else. So I'll show you the way that most textbooks would like you to do this problem. Okay? What we're really looking at here is it's the probability that at least one of them is a man. So we're kind of saying, what's the probability of one man and 2 women, right? Or, right, because that's one option. Does that meet the requirements? Is at least one of them a man? Or we could do 2 men and 1 woman. Or we could do 3 men and, right? With me on that? So now some of these we've already done, correct? On the other side of your notes, we already did 3 men and 0 women. Give me the fraction, if you would, please. Non-reduced. Because it's or, remember, and or means to add, right? 10 over 220. So we already did that one. I don't know where I was going with that, but I saved it. All right. Which other one did we just do? 1 man, 2 women, and that was what? 105? So we need 2 men and 1 woman. So that would be, if we did the math, 5 choose 2 times 7 choose 1, right? Because there's 5 men in there to begin with. All over 12 choose 3, right? Well, 7 choose 1, you should know that one. It's 7. 5 choose 2 may or may not be one that you could do in your head. Okay. And so what do we end up with? 70 over 220? Is everybody okay for me to erase this now? Did everybody write that down that wanted it? Okay, very good. So this one is 70 over 220. And then what should we do with these? Because I need this to happen, or that to happen, or that to happen. And is that all possibilities of it getting at least 1 man? If I put those together, are they all? Yeah, that's all of them, right? And so what do we get there? It's fairly probable, right? 185 over 220. So a pretty good percent, correct? Pretty good shot at that. Okay. So that's one way to do it. Yes? Exactly. The other way to do this problem, okay, by coincidence, 5 choose 2 is 10. Yes.
But then how come 5 choose 3 was 10 also?
Because that's okay. So let's go back to this. We have 2 questions out here. We'll go back to the second question, the 5 choose 2, 5 choose 3 thing in a second. Great question. But let's go back to the first question that was asked. Is in this problem, so make sure I go back to that question, right? Could we have just gone with the, basically there's only one more option, correct? In here, and that is that what? What's the only other option here? Is 0 men and 3 women. So there's only 4 possibilities what can happen here. So could we find the probability of this, and would that help me find my answer to the other question? Yes. So what's that one thing I didn't mention? And that is using the complement. Okay. Now, in this problem, was it really any faster? No, because we already knew that number, correct? And we already knew this number. What if I didn't know those numbers? Is the complement a way faster way of accomplishing this answer? Most definitely. So let's just do that one quick and see if it comes out the same. So this is what? 5 choose 0 times 7 choose 3. All over 12 choose 3. Well, 5 choose 0 is not 0. It is 1. Yep. And 7 choose 3. Is it? Yep. No. Yes, 35. I had to do the math. No, I know exactly what he did. So if 0 men and 3 women is 35 out of 220, that is the only option that is not carried by that. So what we can do is take 1 minus that, and the 1 we would choose in this case is 220 over 220, correct? So we would take 220 over 220, subtract 35 over 220, and we would get 185 over 220. Okay? Are we clear on that? Okay? So you have to read the problem, find out what information do I have already, and which way is going to be quicker for me. Okay? Any questions on that? Okay, the other question that was brought up was in one of the problems somewhere, and I'm just going to add a new page here because we're running out. Well, that didn't work the way it was supposed to. Oh, I'm deleting pages, that's why. Oh well. Is when we did 5, choose 2, and we did 5, choose 3. What did you notice about those? They were both 10. Why is that? I look at it this way. 5 choosing 2 is the same thing as 5 not choosing 3, correct? If I had 5 of you here, is choosing 2 of you the same thing as not choosing 3 of you? Do you agree? Really, in reality, they are the same thing. Choosing 2 or not choosing 3 of you is the same thing. Is choosing 1 of you and not choosing 4 of you the same thing? If I had 5 of you. It is. Mathematically, though, here's why it works. Because you take n factorial over n minus r factorial, So this one ends up being 5 factorial over 3 factorial, 2 factorial, right? This one is 5 factorial over 5 minus 3 factorial, 3 factorial. Are they going to mathematically end up being the exact same thing? Okay. But in reality, do you understand what I'm trying to say? That seeing the order doesn't matter in a combination. If I only had 5 of you and I wanted to choose 2, it's really like I'm saying I'm not going to choose this 3 over here, or vice versa. So it should actually be the same answer. In reality and mathematically, they should come out the same. Okay. Very good question. Okay. Now the only other thing that you saw here, and hopefully I didn't delete it, but I may have. And I did, of course. Well, let's find out if I did. Yep, I did. I wonder how many times I can hit undo. Is it doing anything, though? Is it really? Well, let's see if I can get back. I spent a lot of time on that chart, too. That would make me sad if it was gone. Oh, hey, there it is. All right. I know for some of you I need to sometimes supersize it. Here is basically the distribution of what we just had. I put each one in there individually. There were 4 options, correct? So 3 women and 0 men was 0.16 if you did the decimals. So what type of depiction are we looking at? What would this be called? Relative frequency histogram. Very good. Okay, it took a while. Now, could I obviously have done a frequency histogram? I could have, but I chose to do the decimals, and I tried to make it about how it worked out. How come, because there's only 4 options, how come this isn't symmetric? How come they're not each 25% chance? How come this doesn't work out perfectly symmetric? Because don't you think it should? Why doesn't it? Because are they pulling? Is the probability of getting a man and the probability of getting a woman the same? No, they are not. And so once I start pairing them together, does this have to end up symmetric? It's not, because those probabilities are not the same. Okay? But this is what it would look like. And so what would possibly be a good description of this distribution? Skewed right. And what did you just tell me? You described the shape. Okay? And then obviously it's very hard to do standard deviation and on the other ones on this one, but remember, the center seems to be right about 2 women and 1 man, correct? That's about where the center seems to be. Okay, on average, that's what you would expect to have happen if you actually did it a lot of times. Okay, and the deviation's not all that much. Okay. Any questions on what we covered today, other than why I deleted all those pages? I don't know. Okay. There was one more question from yesterday, and that was, did any of you think of the royal flush question? Did you think about it? What the answer would be? 50 choose 5 would be on the bottom, agreed? What was that number from the other day? I know that was a couple, no, that was just yesterday, right? 2 million, something like that, right? 2,598,960. And what does that number represent? That's just being 5 cards. Now this would be what would be called, for those of you that are unfamiliar with poker, this would be called 5-card stud. Meaning you get the 5 cards, that's all you get. You don't get to draw, you don't get to switch them out, that's what you have. Okay, and why did we choose C again in this instance? Yeah, when you get the cards, you have to get the royal flush in that order. Do you have to get the 10, then the jack, then the queen, then the king, then the ace? No, you don't. But they do have to be the same suit, correct? So really, let's think about that. How many royal flushes are there? There's only 4. So the probability of being successful is there's only 4 ways of being successful. And that is either getting the royal flush of diamonds, or of hearts, or of spades, or of clubs, correct? Now you could look at it this way. If I want a royal, there's 2 ways to look at it. You could just flat out know there are only 4 possible royal flushes. Or you could say, I need 5 cards. You know what 5 cards you need, correct? And I have to choose all 5 of them, correct? But that's just for hearts. Or I could do it for the other one. So really we know there are 4 of them, correct, to choose from? Okay, so you could look at it that way. So right there, 4 out of 2,598,960 is the probability of getting a royal flush dealt to you. So not very good. Yeah, so what is the percent on that? Now that's the percent. So there are 2 more dots. Nice. So there's their percent chance. So, but remember, just because you got dealt 2.5 million hands doesn't mean you got 4 royal flushes. Okay? That's the probability of getting it dealt to you. And that's assuming no wild, no drawing, it's just you got it. Okay? So not very probable. See, you ask questions, and I think about them.